Welcome finally to the second of 4 in the MSSE Industrial Seminar Series for 2021. We're back in person, along with all of its, fun. So thanks for being here. Thanks for showing up. I'm really happy to introduce Alan. He's going to talk to us about cryptocurrency.
I am. Now, can I switch to the actual screens, Kevin, and not interrupt anything happening here? I'm trying to just get back to the slides themselves.
So now you can see that and it's on there.
Okay. Let me full screen that so I can see stuff. Hi, good morning. My name is Alan Jeevanathan, and again, I apologize for being late. Actually, I was flying for work until Wednesday, and I just got back Thursday morning. Then everything just didn't seem to work for me in the last 48 hours in trying to put everything together for this seminar. But I am a graduate of this program. I actually graduated from this program in 2005, and I am in absolute gratitude of what I've been able to learn and do. I'm sure everybody has different reasons or what brought you down this journey or through this path. For me, I grew up in Toronto, Canada, actually, and I went to a school called McMaster University, which is just outside of Hamilton, Ontario. And I did a degree in computer engineering, which was a mix of computer science classes as well as electrical engineering classes, but never really a focus on anything. So once I actually graduated and I started working, I didn't really feel like I had a grasp on different things. I kind of knew a little bit here, a little bit there, but something was missing. And so that's how I eventually discovered the MSSE program and enrolled. And I felt like it helped cover a lot of those holes that I thought was missing in the computer science aspects of my education and my background. So I'm absolutely in grateful gratitude. And I wanted to kind of do a little bit of a transition as to what I was doing. So when I first started working, I worked for a company back then, it was called Guidant. They were bought by Boston Scientific, but I was working on developing testing tools for medical devices, for pacemakers, defibrillators, everything sort of in that cardiovascular space. But I kind of wanted to make that switch and start actually doing more development type work, but wasn't completely confident in what I knew what to do. So once I kind of enrolled in this program and was able to learn a lot and through all the different projects and the coursework that we did, kind of transitioned from there and then worked on different roles, doing lots of different development in that space. And I was at Boston Scientific for about 8-9 years, but I kind of sort of realized at that point where my career wasn't really going anywhere specific. I would look at my resume year after year and I'm like, I'm not adding anything new. Everything is still kind of the same here. And I enjoy software development, but I wanted to see what software development was like in other industries. I've been a medical device all this time. So that was kind of my start of being an accidental contractor, where from there, I've worked in different places for a number of years. So in retail, I worked for Best Buy. In legal, I worked for Thomson Reuters, both about 4 years each a piece there. A place called Trimble, it's called PeopleNet. They do work in big data and trucking. But one thing I kind of learned is that from going from industry to industry, I was able to take what I've kind of learned and picked up in one place and apply it to where I was going next. And it was an absolute blessing to be able to do that and learn and continue to learn. And I kind of see myself as a journeyman, I think, or at least for the next little while, going from place to place. So right now I'm at Health Partners. I've been there for about a year now. And somewhere in there, I was at Siemens for a while as well, too, for about 2 years. So I've been doing work in this space for about 22 years now. And absolutely love it. Love software development. And one of the things I, especially now, with being able to do this work is like, I enjoy being in the office, but being able to work remotely has been a blessing as well, because I was working long hours and I have 3 young kids. And I was always coming home, I don't know, 6, 7 o'clock at night, basically just putting them to bed and then not really being able to spend time with them. But since COVID has happened and I've been able to be at home, to work at home, have lunch with them, go visit them at the school, it's been amazing. Absolutely, I've loved it. So that's kind of been my sort of journey so far in software engineering. I've absolutely enjoyed what I've done. And on the side of things, I've always been a hobbyist. So even beforehand, my first computer I got when I was 6 was a Commodore VIC-20, and I've always been a tinkerer, a player, fiddling around in that sort of space. And that's what kind of led me into playing in different areas, cryptocurrency being one of them. And I am by no means an expert. So if you guys have very technical questions for me, I can probably find out what I need to know to be able to explain things, but by no means an expert. But I have been playing in the space a lot And we have worked with some startups on the side as well too, including doing all sorts of stuff related to mining in different areas, and different coins and whatnot over the last, I don't know how many years now, maybe at least 7, 8 years as well too. So I'm sure everybody here maybe they know about cryptocurrency, but maybe has some familiarity with it. But raise your hands if you guys have a Coinbase wallet. Yeah. Now raise your hands if anybody here has tried mining, and not mining necessarily with using just software, but doing it from the ground up. So there's 2 ways you can mine, I suppose. There's one way you can connect to a site and they'll utilize what you have in terms of whether, depending on the type of mining, but has anybody else tried any actual mining versus actually building a rig itself and trying to just let it power up and do its thing? Maybe a little bit. Okay. Cool. So we'll talk more, and get a little bit more into that in a second. I should just double check as well too. I don't know if I have any feedback. So everybody who's watching at home right now, can you guys all hear me? I'm assuming that's probably the case, but should maybe just double check. I'll check the chat just to see. Okay, I'm gonna just assume people can hear me at home.
Yeah, they're not chatting.
Okay. All right. All right, so everybody probably has some sort of crypto story in terms of maybe you wanted to buy something but didn't, you were intimidated by it, was wondering, what is this space? We hear about it all over the news now, and all the ups and downs and all the sort of things that play with what's happening all around the world. So now there's a South American country that has adopted Bitcoin as its official currency for people to use. But what does that mean exactly? How do you utilize, how do you spend this cryptocurrency? How do you do your day-to-day work with this? So I want to take a quick step back and to kind of talk about my first sort of touch with Bitcoin. It was Bitcoin at that time, but back in 2014, so not the actual Black Friday where you shop, but there was another Black Friday that happened where before that, September of 2014, online poker was legal and you could play online. And I used to love playing poker and online at Canterbury Park, wherever it is. It was always fun for me. But then the government came along and introduced a bill as a bylaw, as part of one of their bills, to actually block banks from being able to send money to get money from banks to be able to utilize them on poker sites. So they called that day Black Friday because that's when all of the poker sites were down in the United States and you couldn't play online poker anymore. So fast forward maybe a good year and a half from then, sites were still operating, but they were only accepting cryptocurrency if you wanted to get in place, since you couldn't use money from the banks. So me thinking, hey, maybe I could try this. I haven't played in a couple of years since it all kind of stopped, but let me give this a shot. And at that time, Bitcoin was only $100 a pop. So I bought maybe about $800, $900 worth of Bitcoin, blew it all on poker and pizza. Now, if I had those 8, 9 coins today, I think as of this morning, they were worth about 70,000 each, maybe 80, 75, somewhere there. I'd have a lot of money, but that's okay. Those games were fun, I suppose, at that time. But that's what it kind of all started. But then I was curious because at that time, it wasn't easy to be able to just connect to an exchange, which is where you would go to get cryptocurrencies. But you could do it, but it wasn't straightforward. You had to find some other ways of transferring money and doing this to sort of get those cryptocurrencies into your wallet. Today, with the advent of Coinbase and other exchanges as well too, it's much, much easier to buy things. But that got me thinking, hey, how do I start mining? How do I start trading this? This could be a fun side project to give it a crack at. So I did at that time try to mine, and I did start mining, but it was very, very difficult and expensive. And I'll show you guys a couple more pictures coming up in my presentation of the stuff that I've been doing over the years. But the amount of money that I was spending in electricity and hardware costs completely outweighed the value of Bitcoin at that time. And the thing is as well too, which we'll talk about, is that as you are mining more and more, it gets more and more difficult to be able to get a block on the Bitcoin, the actual blockchain. So I would sit there, the computers would run. And the thing is, if you are trying to mine solo, it is, at least with Bitcoin at the time, it is near impossible to try to hit a block. But if you're part of what's called a pool, which is a group of people all trying to mine together, if any one particular person hits a block, was able to mine and grab one of these blocks, which again, sorry, if I throw a whole bunch of terms out, we'll definitely cover it as we go along. But if you hit one of those blocks, then everybody shares. Now, the person who hits the block typically gets a larger percentage of that block or the value of that Bitcoin, and everybody else will then kind of distribute the rest of it amongst themselves. So I was trying, and I was maybe getting 0.0001 Bitcoin at a time, and it wasn't adding up nearly next to how much I was spending in electricity. And my wife was like, we can't be getting these $700 electricity bills every month after month after month with nothing to really show for it. So at that time, I kind of stopped with the Bitcoin mining at least, but it was really interesting to at least try that. So I feel like I missed out on that boat because I was kind of doing something with it. And if I just let it keep going, given how everything has skyrocketed since back then, it could have been worse than today, but I learned a lot, which was great as well too. So after that, again, being a sort of a hobbyist and interested in this sort of space, I wanted to figure out or understand what all this stuff meant. What exactly is a blockchain? What exactly does it mean to be able to build a blockchain? Why do all things have to, with cryptocurrencies, associate themselves with blockchains? And so I started working with a couple of friends and trying to write our own blockchain in the last maybe 2 years or whatnot. And it was more just to play with it, just to see if was there something we could do, maybe even create our own coin. Okay, that'd be interesting. Just makes it seems like everybody else has been trying to do it or attempting to do it. You hear things about Dogecoin and this coin and that coin, and it can be too complicated. Now, the thing is, there's no really set of straightforward instructions if you were to go online to figure out how this all kind of works. But there are so many forums, so many people that are willing to help, which I've always found fascinating. The community is vast, and everybody is there willing to kind of pitch in and give you information or whatnot. And I've always found that also just as fascinating. So kind of through that and kind of working with different people, we were able to kind of build our own blockchain. And I was going to walk you guys through that and show you an implementation of it. But unfortunately, can't connect this laptop, but maybe we can figure out a way. The good news is I do have snippets of code actually in the slides to show you guys, but if I can get this working at some point, it'd be nice if I can actually show you a live running blockchain and a blockchain application as well too. So yeah, so I'm hoping that what we'll try to do this morning is kind of talk about what blockchain is, what it means. I was going to show you guys what that looks like from a code perspective and building an API around that, and then creating a peer-to-peer server for multiple contributors. So being able to have instances of these blockchains living on different people's machines or nodes, whatnot, being able to communicate with each other with the idea of building this blockchain going forward. And then we'll talk about what this whole thing called proof of work means, and then a transaction system for any sort of cryptocurrency. Are there any questions so far? Oh yeah, so you could implement, of course, this in any language of your choice. I happen to use Node.js because at that time I was working on a Node.js project at work, and I thought it'd be good to keep kind of building on those skills and utilize that. And it was actually very, very straightforward to be able to do it. But I actually have all of my stuff documented, all the code pieces and whatnot. So maybe afterwards, once I can figure out with Kevin a good place, I can kind of drop things off, resources for you guys to kind of look at if you want to see it working. And you can run this on your own machines as well too, and kind of see how an actual working blockchain. All right, so what is the blockchain and why use it? Now, the thing is, we keep hearing the term blockchain with cryptocurrency. But the thing is, blockchain is a technology that cryptocurrency is only one use case for it. Now, it's exactly what it sounds like. It is a chain of blocks, and a block being just a piece of data. Cryptocurrency is just one way it's being utilized. But more and more, as I've been kind of delving into all of this, I've seen that other industries outside of cryptocurrency are also trying to utilize the technologies behind blockchains in order to just utilize that. And I think we're going to see a big sort of movement going forward where we're going to see it in other industries as well too. Now, I've seen a lot of discussions where people are like, no, there's no way this is just going to be just tied to cryptocurrency. But I'm seeing a lot more job postings for blockchain engineers, which is interesting. So as I'm seeing more and more of these discussions and whatnot, I see that just like the internet 15 years ago, people, or actually more than that, of course, but people were like, oh, this is never going to work. People are not going to use this. But obviously, that's not true at all. And I think 10 years from now, we're going to see blockchain being a technology that's used all over the place as well, too, not just with cryptocurrency. So the actual formal definition of blockchain is that it's a distributed, decentralized ledger that stores data such as transactions, and that this ledger is publicly shared across all nodes of its network. It's kind of a mouthful. So we'll kind of break that definition down and go through what the key words are here itself. But the storage itself consists of multiple blocks of data that are chained together like the links of a physical chain. Now, everybody here probably has a bank account. Put your hands up if you've got a bank account, whatnot. So everything that happens in your bank account or how the bank tracks all your stuff, they're the central authority. So that is a centralized system. So the difference between a centralized system and a decentralized system is that with blockchain, that ledger, because the bank has that ledger, the ledger will say, okay, this person's paid this amount, then they took this money out, they made this credit card purchase, so on and so forth. Whereas with blockchain, that ledger lives on every single node of that blockchain network. So every single thing that you would do, or he would do, that would all be categorized and stored in every single node of the network. So what does that mean? Well, it means that then it's a trustless system, meaning that it's completely transparent. So you can see what exactly is happening on each node and all the transactions that are happening. And of course, it doesn't mean that they'll see your name and you have this much crypto or that person this much, because you will have a digital wallet, so an actual hash that will represent your wallet or ID over there so that nobody else could actually see or type to you specifically, but that would be your public key for people to see. Now, this is sort of a very high level example of a blockchain, where each of these guys is a block, and in each one of these blocks, you've got some information. Now, in order to have an additional block on there, usually there's, and we'll get to this as well too, there's 4 different pieces of information that you need. But the biggest piece is that you're going to have this hash. This hash is made up of typically, and again, this is something that's more related to Bitcoin. Other cryptocurrencies might use other pieces of information in building this hash, but typically you'll have a timestamp, the hash of the previous block, the actual data itself, and the data itself, and there's one more other thing that's not coming to me at the moment, but that then is put together, concatenated, just like a string, and then hashed. And the nice way, the thing is with a hash, what makes it nice is that when you've got that string and then you hash it, then you get this, and in this case, at least with Bitcoin, the way it was laid out in the white paper was to use the SHA 256, that if you have the same input and you do a hash, you will always get that exact same output. Now, if you change even one character in that initial string, it will give you a completely different hash as an output, completely different. So you'll see different characters all together, not just like one thing changed, but it actually is a completely different unique address. So in doing this and getting all this data, you continuously keep building onto these blocks that you have over here with this information. But this is kind of a high level sort of overview of what exactly a blockchain is. And it's just like what it sounds. It's a chain of blocks, where a block is basically essentially a piece of data. Now, we kind of touched on this, but I'm going to kind of go back to a little bit more detail only because it's part of the formal definition. But a ledger is a record-keeping book that stores all of the transactions of an organization. As I mentioned before, like a bank will have a ledger that shows everybody's transactions and what they do, recording contracts, payments, movements of payments between different individuals or different banks or whatnot, so that the organization can track all of its economic history. Now, as a ledger, the blockchain has the purpose of storing transactional data. The blockchain is the ledger. So any transaction that's made, whether it's you're sending crypto to this person or you're receiving it, everybody will be able to be aware of it. Now, what makes this interesting is that, at least I can see this from my own experience, since I've been mining at home, if my computer crashes or something goes wrong with any of the data, I need to get that entire ledger back up on my system. Every node is supposed to be identical. Now you'll imagine now, you could be talking about years of data. So it will take a crap load of time to sometimes get fully what we call synced up on the actual network itself too. With some of the coins that I'm trying to like play around with now and mine and whatnot, it's a little bit faster because they're newer, but some of the older coins, when you try to sync up, it could take you weeks until you're finally caught up. But rest assured though, everything that has happened is everywhere. So that's the nice thing. So when I was mining and I had maybe, I don't know, very few, but like 5, 6 coins of one type of coin, everything crashed. I think I've had a power outage, I had some corrupt data, so I had to get everything back up and going again. When I did, it said my wallet was 0. But then as I was syncing up and getting all that data back, and slowly by slowly, I could see my wallet slowly catching up, syncing up, because it was getting all of those node transactions that we saw on that previous slide and getting that up locally. So finally, when I was fully synced up, I had my wallet again, I had all my coins and whatnot, and it felt interesting to see that this was all out there. So it didn't matter if anything crashed or got corrupt in my system, because this copy is out there on every all the different nodes of the network. I could get everything back and be synced up again. Now, the important thing is to keep your private key safe and that nobody sees that piece of it, because if somebody were to use that, they could connect in and then be able to get synced up and then be able to access that person's wallet and then spend that crypto if they needed to. But the interesting aspect that I want to kind of convey is that everything is out there. And so once you're synced up, you'll get all that data back, and then you can see exactly this ledger on your local machine as well too, and what your wallet looks like. Yes, so the fact that, so we talked about decentralized, and the other big key word in that definition is the fact that it's distributed. And so you have your own ledger locally, but there are going to be many, many, many nodes on your network, on your system. So usually when you try to do any sort of mining, you'll download the Bitcoin software, or you'll download the Ethereum software, or you'll download whatever it is. And then there's a central server there, but then you will also be connecting to other people's nodes as well too to get all that ledger information. This system is truly distributed and is out there living in all the different nodes, but they're all replicas. So that's what makes it trustless, as well as the fact that it's all distributed. Are there any questions so far? Okay. So kind of touching on this again too. So the fact that you've got a centralized system like the banks and other things as well too, where you have one entity that records the data. The central entity has all the power. They also have the full authority to fine you. So when you pay something late or get bank fees or reward you for incentives for using their credit card or whatnot, and you're completely trusting that entity to make the right decisions. But of course, it also means that they get to collect fees on every transaction and so on and so forth. Whereas when you have something with blockchain, now everyone records the data, everybody has equal power, it's fair and a transparent system. I mean, we'll talk about what the drawbacks are in a second, but you can see everything that's there, and that's what the people would tout it as being fair or transparent, and the fact that it's trustless. So we talked about, okay, so no middleman fees, it's highly secure. Oh, and this is another big thing as well too. Given that you've got all of these different nodes and that they're all replicated across the network, there's no central point of failure. And it's very dependable since all the nodes are recording transactions. All right, and I wanted to just kind of touch again on that definition, but I think that makes sense. Does that make sense to everybody what a blockchain is? Okay. Now, I mentioned that with cryptocurrency, that's one example of something that's using blockchain technology. But again, blockchain can be used in other ways, and we're slowly seeing it being used in other ways. But cryptocurrency has 3 specific backbone pieces to it. You need to have a secure blockchain, and then you have 2 other things. You need to have wallets, so then a means for people to be able to keep and store and exchange actual crypto, and the aspect of mining. So those are the 3 real main things for any cryptocurrency. You got to have a secure blockchain, you got to be able to have wallets, and you got to be able to mine. Ooh, that's a bit small there, if you guys can read that, but I'll read that, sorry. So one question is that everybody has public access to this, couldn't somebody manipulate the system? Now, the thing is, not really. Now, there's been a lot of cases now lately of hacking happening, especially in different spaces, like actually in the health insurance space, there's been a lot of ransomware type things where Alina Hospital and the Fairview hospitals were all under attack, where they had to pay a certain amount of money so that they could access your stuff because hackers had come in and kind of hacked all their stuff. That's because a lot of that lives in one place. So they can access the one thing, take control and whatnot of their servers and do their damage. Whereas when you're using the blockchain, when you've got many, many, many nodes distributed all around the world, in order for somebody to do any sort of real damage, they would have to take control of many, many nodes to be able to manipulate, but that's not really realistic to be able to do. So that's one big aspect of why using the blockchain is a big deal. Now, I have some blanks here because I want to ask you guys a couple of things as I was going along here. But to handle this problem, what do you guys think cryptocurrency uses as its layer of security? And I'll give you a big clue. It's in the name. Very simply, it uses cryptography. And that's all it really is. It's a lot of this terminology, as you kind of play with it and you dwell into it, sounds like it's supposed to be complicated, but really at its very basis, it's pretty simple. By using some sort of cryptographic system, they could then use that as a way of protecting and being able to take control of their information. Now, the way that works is that if you are a node or a user on the actual network, each individual person or node would have both a private key and a public key. Now, your public key is then exposed to everybody, and both of them are tied together. Now, has anybody done any sort of cryptography work for fun or like locally or whatever it is? So are you familiar with that sort of RSA sort of system where you have two keys and they're tied there together? Now, your private key, you can use that to encrypt your information. So in this case, with cryptocurrency, with your private key, you could then encrypt your data of your block and create a sort of signature. And then this public key that's out there that was generated at the same time as your private key can be used to decrypt the actual information to see if it's valid, if it's okay or whatnot. So those two keys kind of work hand in hand when you're doing that. So okay. So the second aspect we were talking about outside of blockchain that is fundamental to cryptocurrency is wallets. Now, wallets are objects that store the actual keys. So the private key as well as the public key of an individual on this network. Excuse me. And the wallets themselves also track how much cryptocurrency is entitled to any particular person that's on that network as well too. The public key is the actual address. So that's what everybody else would see for your wallet. And you would then use that to be able to get money. Somebody was trying to send money and whatnot too. And it helps generate the signature to actually sign off those transactions that are being added to the blockchain. Okay, the third aspect. So we've got blockchain, we've got the wallets, and then we got mining. So most of these cryptocurrencies that are out there today allow some sort of mining to happen. Now it's interesting. There's one particular coin that I've been more interested in lately called Chia. It's came out maybe just about a year and a half ago, but I wanted to get in early to understand how that all worked and try to mine, but they don't call it mining. See, the biggest downside of cryptocurrency mining right now is the electricity consumption. I think in Singapore or Malaysia, they destroyed many, many miners because it was really tapping into the country's power grid and bringing it down with all of the people trying to do mining and all the electricity that was being used. So there's alternative cryptocurrencies that are coming along using other types of algorithms. Bitcoin uses the proof of work. Chia and other sort of green cryptocurrencies use what is called proof of space, where you, instead of having GPUs and powerful CPUs to necessarily do the mining, you actually just need to have a whole bunch of hard drives. So and I'll show you guys some of the stuff I did there, and we'll kind of look a little bit more at Chia as well too, but I bought a whole bunch of hard drives and got a machine set up to build this space, but they don't call it mining. To be more green, they call it farming. And instead of doing this mining to get these Bitcoins, you're doing farming to make plots. And then when you have more and more of these plots that you're making in the space that you have, Then similarly, as you're kind of solving these complex algorithms using those spaces, you're rewarded Chia coins. And so when Chia coins first came out, they were worth maybe like 1,700, 1,800 bucks a coin. Now they've dropped to about 200, 300, but it's not as expensive to get into Chia farming, but the cost of the hardware and drives still way outweighs the cost of actually getting a reward. So the thing is, a lot of people, when you see on the news who are doing farming, who are mining, they're typically doing coins that aren't easily purchasable on any exchanges yet. Usually it's like something like, Shiba Inu or Dojo, whatever it is. Now you can get them on Coinbase or whatnot. But these guys have been busy farming and mining these things at home and sort of building up this wallet before the public could really buy it. Now there's ways you can join to certain exchanges and do this sort of purchasing, but usually they're in Europe or maybe just in other particular places. And it's definitely not straightforward to kind of just jump into it. So it's fun as a hobbyist, as a pure scientist, like, hey, I want to give this a shot. I want to play with this. I want to sort of see what it's like. I want to understand what's happening here. And it'll cost a little bit, maybe, but sometimes if you build something, and so I know a few people have kind of built up a stockpile of like Dogecoin whatnot before it was able to be purchasable. And then when Dogecoin kind of went big, when Elon Musk does his tweets and whatnot, and whenever you guys have been kind of following that, but then you see this big, huge sort of cycle of ups and downs, especially right before he was hosting on Saturday Night Live. When things went from like 10 cents to like 90 cents. And then right afterwards, I think his mom made a joke in a skit or said something on the show, and then it just tanked right back down again. So it's funny to see these cycles happen. It's so weird, all this volatility. Like, is there really some undermining back-end weird things that are happening that we don't understand? So there is definitely an element of sort of gambling. Sometimes it feels like that's what it is, because there's so much volatility, at least with the stock market, and even with the stock market as well too. You can see the ups and downs, but not as crazy as it's been with crypto. And I wish I had some more slides here to show you guys the specifics with the rise and fall, but how things have changed. But I think it was just in January, crypto had fallen down to like 20,000. Now it's on its way to almost 80,000, Bitcoin specifically at least. And Ethereum was down to 600-700. Now it's almost at 4,000. But again, it's that whole up and down that we don't really fully understand what is it that's controlling it or what's doing, because it seems to be it's either tweets or it's like just funny information in the news or whatever it is that seems to have this weird impact on the cycle. So the point I'm trying to make is sometimes with some of these coins, it's fun to maybe just investigate to see if there's a way you can just mine, particularly ones that you can't buy yet, because by the time it is accessible to the public, they're probably worth a lot more then than they were back when you were trying to mine them, which is why I've been kind of playing on with Chia, but I don't know if Chia is actually going to go anywhere, but we'll talk about that in a second. So miners, yes. So they do work of adding the actual transaction to the blockchain. Now, when people submit transactions to the network, it takes time for it to show up. So those transactions, we call those ones temporary, we call them unconfirmed. And so miners will take a group of these unconfirmed transactions and they'll put them within a block in the actual chain. The act of mining is done through solving a very complex computational puzzle called proof of work. Now, this algorithm is difficult to solve and it's very computationally expensive, which is why you have those electricity and as well as hardware costs that are involved in there as well too. But a lot of people kind of leave their machines just running, and even though it is utilizing that, they'll let it go just to build up with the hope that that coin will have more value in the future. And that's what you're kind of banking on. Typically, the cost of entry is always expensive, but you're hoping that what you're trying to mine will eventually have some value down the line. So once solved, the miner can add the actual block to the other miners that are on the network will actually verify what's there. Now, why would a miner spend the money on hardware and electricity to do the mining at all? So miners, again, and this is maybe already self-aware or self-apparent, but they're rewarded, of course, for adding a block to the chain. And I mentioned this earlier. If you're the actual miner who's able to get over that hump and actually solve the piece of that puzzle there, you usually get more of that reward than the other people who also were able to particularly contribute to the solving of that block at the same time. And usually, I don't remember what it's now with Bitcoin because they kind of adjusted it over time, or with Ethereum, but with Chia, the way it works is the person who found it will get 1/8 of the reward. And so it actually works out to one block, which is 2 Chia coins. They'll get 1/8 of its value, and everybody else will share in the 7/8 of that. And then so that you'll get fractional amounts. And if you're kind of mining or farming or whatnot over a period of time, it adds up. sort of, depending if the price of the coin goes up or not. Okay, so I'm going to talk a little bit more about Bitcoin and just kind of take away the smoke and mirrors around what it is and where it came from and how it's like, why is it adopted so widespread today? So Bitcoin was the first decentralized cryptocurrency back in 2009. And now today, of course, it's probably the sort of the big whale of cryptocurrencies out there that people kind of want to keep their money in, because that's what they see as supposed to be stable. But as I mentioned, I haven't really seen that stability given that it's had so much change even in the last 9 months. But there are other coins as well too, Bitcoin just being one of them. But Ethereum is sort of the second big one that people talk about that uses a different kind of technology or called smart contracts in the background. But there's also Ripple, Litecoin, and many, many others. In fact, people are just trying to make all sorts of different coins with like funny, catchy names, hoping it'll just catch on and become big, like Dogecoin, or many, many other ones too. So there's like literally thousands of coins now that people are implementing out there. So I'm hoping I'll be able to show you guys kind of like the basis of how you can build your own blockchain and make your own cryptocurrency. And then you can take that and play with it and see what you guys think and do stuff with it. So I actually had everything running up on this machine, but I'm kind of annoyed that we can't connect it. Oh, yes. So I mentioned that blockchain is a technology. And so cryptocurrency is just one example of how we can use it. Now, you can use, and some countries are right now, in different counties in a place called Sri Lanka, which is an island just south of India, are using blockchain for voting registers. So, with the election that just happened recently, they were trying to utilize that technology so they could track everything using blockchain. And some places are talking about using blockchain technologies as being able, as a way of supporting documentation or using as an identification system. So by having this all sort of on this network, you can kind of see everything that's there. And so there isn't as much identity theft or fraud by utilizing something like blockchain for that. So again, will this really change the world? Is it too complex for widespread adoption? I mean, we said the same thing before about the internet. Right now, we are very dependent on banks and whatnot, but I really wouldn't be surprised given that I'm seeing more and more job postings for blockchain engineers and whatnot coming out that 10 years, 15 years from now, that this will be something that will be adopted and more mainstream. All right. So Bitcoin, the white paper for it was first published back on October 31st, 2008. So yeah, almost 13 years ago now. And it was published by this person named Satoshi Nakamoto. Now, the reason why I say person is that nobody knows who or if this person really exists. There's been no actual confirmation of an actual person named Satoshi Nakamoto. They're wondering if it's a group of people just using this pen name to kind of show this. They're wondering if it is just one other person, but nobody really knows who or what this guy is. But there was a paper that was published, and it kind of outlined these ideas for the things that you need for Bitcoin. Now, this person or group of persons actually is holding the majority of the Bitcoin right now. So if they were to do something, sell or whatnot, it's probably worth billions, I would think, right now, given how much that is. But nobody knows who this is, and nobody has stepped forward, or whether this is a real person or not. So has anybody heard the name with Bitcoin and whatnot before yet? So the thing is, if you were to go and read the paper, you should read it. It's actually very well laid out. It's very interesting, and it's actually it's a good read. It will help you guys kind of understand a lot of the pieces of how it all works. But this is what they laid out. There's, I think, 12 sections in there, including an introduction and a conclusion. So there's really 10 sections of actual information, but it talks about all the different pieces in the white paper of how Bitcoin could operate or how it could be implemented. So the white paper kind of goes into transactions, and it talks about some of the stuff I talked before with using the blockchain, where you've got these different blocks, and inside of the blocks, you've got that signature that I mentioned, as well as the hash. And the hash, again, is usually a hash of specific pieces of information, timestamps, data, the previous block's hash, whatnot, that's then concatenated together as a string, and then hash to make the actual code for the block itself. So the Bitcoin, that paper kind of talks about that in specifics. And then it talks about having a timestamp server Now, what you'll see in that code that I'll show you guys in a second is that I'm just using Node.js. I'm just using the time stamp function that JavaScript provides to kind of stamp it. But Bitcoin has an actual like sort of different servers that are set up with where you would get your actual timestamp for. That could be your source of truth, and that's utilized and then in the blocks themselves to create those hashes. Then it actually, and this is a good read, and it's probably a good thing for, and I can kind of talk a little bit at a higher level, but the actual proof of work algorithm is actually outlined in there because it sounds like it's complex. It's like, it sounds really strangely wordy, but if you were to kind of go through it, you can kind of read it together and sort of talk about it if you guys have questions about this, but it kind of outlines it very clearly with lots of diagrams. So again, highly recommend that you just go out there and take a look at that white paper because it kind of breaks it down. So proof of work, to implement a distributed timestamp server on a peer-to-peer basis, we will need to use a proof of work system similar to Adam Back's Hashcash, rather than newspaper or Usenet posts. The proof of work involves scanning for a value that when hashed, such as with SHA-256, and that's what Bitcoin does use now, and a lot of coins do use that for their hashing as well too, but there's other ones you can use as well too if you want to hash, not just 256, but 256 refers to the number of bits, which is then 32 bytes. So you will get a 32 character string of your hash for each of these blocks. The hash begins with a number of 0 bits. The average work required is exponential in the number of 0 bits required, but can be verified by executing a single hash. For our timestamp network, we implement the proof of work by incrementing a nonce in the block until a value is found. That's the whole thing with finding the actual blocks as you're doing this whole solving this proof of work algorithm to find the next block that's going to be in this chain until a value is found that gives the block's hash the required 0 bits. Once the CPU effort has expended to make it satisfy the proof of work, the block cannot be changed without redoing the work. As later blocks are chained after it, the work to change the block would include redoing all the blocks after it. So once you find a block, it's typically then fixed. But the point that this is trying to make is that the more blocks you find, the harder it is to then find or mine that next block to add to the actual blockchain. Now, there's other pieces in that white paper as well too. I want to just point this out as well too, but it talks about how the network should be laid out and the whole incentive piece of how the reward should look like when somebody discovers a block and how that reward should be shared. So again, highly recommend if you guys can go and take a look out there. And then you guys can kind of see all the other different sections of how things is. I didn't fully understand. I don't know if that's utilized reclaiming this space right now on that network, but definitely the payment verification and the combining and splitting of values and then calculations, it's all sort of in there and laid out nicely. All right, so what I wanted to show you guys next was how we could implement our own blocks. And again, I really apologize. It would have been cool if I could have shown you guys on the laptop, actually it running and whatnot. But once I get you guys that code, and I'll have instructions that are like nicely laid out so you can just get Node.js installed and you can actually see it in action and it's all documented pretty well so that you can go through it and understand what it's all doing as well too. But we'll talk about it here as well. So the block itself has to have 4 pieces of information that it's going to use that we're going to have out there. You're going to have the timestamp. Again, and again, I mentioned it, we don't have a timestamp server, but you'll just use in whatever language you're using that library's timestamp function. You'll have the hash of the previous block before it. Then you'll have its own hash that's based on then its own data that you're adding to that block. And of course, then the data itself that you're trying to store. So quite simply like this. So this is an example. It's actually very straightforward. Now, how many people here can understand JavaScript or have developed in JavaScript? Have a good idea? Okay, good. So then this hopefully will make some sense. When you play with it, you'll understand it more, but it's very simple. I created a block, and in the block, when I'm creating a block, I'm gonna give it those 4 pieces of information, the hash, the last hash, the data itself, and the timestamp. Then utilizing that, this toString is what I typically use, what people typically use in JavaScript when you're trying to debug in C. So that's what you'll see in the code as well too when you're playing with it as well too, but this is just your basic block constructor. Yeah, okay. Now, since we have these blocks that we're generating, creating on this blockchain, how do you start? What does that first block look like? Since that first block won't have a previous block. in the blockchain, that first block is called the Genesis block for being the first block. And usually it won't have, you can give it any sort of garbage data for its last hash, and it'll just use that to generate the first hash so you can start off your blockchain. So in the code itself too, I have a piece of code over here. I'm so glad that I actually put these in the slides, even though I can't show you this over here. But you'll see right over here, just as simply, I have this constructor over here, or this method in the block class called Genesis, which then you would initially call from your application code to create the actual first block. And then once you create your first block, then you can call your actual block classes and create instances of those blocks to then continue on with the additional blocks as well too for each piece. Oh yeah, okay. And so putting that together with the block and just block, then when you're mining new blocks, so you're going to create a new block, then you'll see in that same block code, this mine block method that will then take that block and the data and then create. Now I put a to do here because I was going to show you guys how I actually implemented the hash piece of this in here. So we'll get to that now. Second, so okay, with the hashes, yes. So for this, I'm using SHA-256 because it's just an openly available library that you can use to hash and encrypt. But you can literally use anything you want. You can pick whatever piece you want. And the way I kind of laid it out and implemented it, you can add your own method that will call whatever library you'd like in order to do that hashing. Now the hash is generated again from timestamp, the last hash, and the stored data. And we're using SHA-256, and it makes this 32-byte, which is 256, where that comes from, hash value for each of the data inputs. And it's useful for block validation. Now, again, very simply, you'll see in the code itself as well too, I'm pulling in a library, an actual hashing library, and I'm using that hash library, and I'm just concatenating that information together. I'm literally just putting in a timestamp, and that timestamp in JavaScript is just going to tell you the number of milliseconds that's passed since, I think, January 1st, 1970. But with that timestamp and the hash of your previous block and the actual data itself, so it could be that actual transactional data, just concatenating together as a string and then hashing it. And that's what's used on for Bitcoin as well now too, in order to make these unique hashes from block to block. All right, now, so we talked about these different blocks. And again, a blockchain is just simply a chain of blocks, nothing more to it than that. So then I have another class in there as well too, that sort of lays out the creation of my Genesis block, as well as adding in each additional block to this chain. So here's my blockchain class. And you'll see that when it's first instantiated, that the first thing it does is it creates that Genesis block, which is then pulled in from that block class, if you can see that there. And then on the chain itself, when you want to add new blocks in, block by block, you can just add in a block just like this by calling the mine block. The mine block then will go and mine your block, whatnot, and then add it to the actual chain. So your chain will just keep growing and growing with each of these additional blocks, which again has just those pieces of information. And then that's kind of how that gets laid out. Now, the next question is, with blockchains, you'll have different nodes. And let's say then one person mines a block. How then do we keep everything in sync on the network? How do we make sure these other nodes also get this information? What if another person finds another block at the same time? How exactly do we make sure then that things are then in sync? Well, there's a couple ways that you can do it. In Bitcoin, the way they do that is they look to see who has the longest chain. Now, so again, sorry, going back to example, because you get to the issue with forks. If one guy found one block and another node found another block, and then these guys are then copied out to all the different other nodes of the system, you'll have a bunch of nodes that are saying one thing and a bunch of other nodes saying another thing. So the way that we get around that is by looking first to see who has the longest chain. Then that longest chain is then taken and then copied over to everybody else's nodes. And then once you have that, then those other nodes that have the discovered new blocks are then added to the end of these. So they call this the longest chain method or algorithm to make sure that all the nodes are in sync on the actual network. Okay, yes. So the next thing I want to kind of mention as well too right now is with Chia. So Chia again is another alternate coin, different from Bitcoin, whereas it uses this proof of space. The proof of space is another type of algorithm that shows that you've got space. And in this case, that space equates to actual hard drives. So I have a whole bunch. This is one of the rooms in my basement right now. I have maybe there's a bunch more in the actual server here itself too. You notice my children's books are now blocked off, so they can't access anything at the back there at the moment. But I have maybe about 50, 60 drives are in there. And this machine, the server is just running continuously, connected to the Chia network, building these plots continuously, and finding a way to sort of get these rewards by using this actual space. Now, again, because the price of Chia has dropped drastically since when it first came out, it's not worth nearly as much as I've already invested into trying to building all this, but maybe one day it'll go. I don't know. We'll see, I suppose. But this again is another sort of alternate coin. 50 drives, and they range in size from 10 terabytes to 14 terabytes. So it's a lot. It's a lot, definitely a lot of space. But again, my whole incentive, it wasn't for financial reward really. It was more because I see myself as a hobbyist, and I've always been interested in how this stuff works. So I want to play with this with the idea that if it didn't work out, I could just sell everything that I had at a loss, not a huge loss, hopefully, just so that I can sort of have the experience to say, hey, I did this. I was able to kind of fill with this because I keep kicking myself over those Bitcoins I sold for poker and pizza. Back then, that would have been worth a crap ton of money now if I had the sense to just leave it alone rather than blowing it all off on a poker site. So that's that. So that's why, and that's how I ended up doing all this Chia piece of it. So that's what I got. Are there any questions right now around this stuff or around blockchain technology or cryptocurrency? The rest of the stuff I had over here was actually in the application itself that I was going to show you guys, but that's okay. If there's anything else that you guys wanted to know? Does that make sense though, how blockchain works and how that's utilized, at least for cryptocurrency, and how it can be utilized for other aspects?
Nodes, like how many are we talking? Hundreds or
oh, millions.
tens of thousands?
So again, it depends on the type of coin that you're using. So in Bitcoin's case, if you connect to the Bitcoin network, there's millions and millions of nodes. With Chia, it's also millions, but a fraction of what Bitcoin has right now. It's just a node is just, again, an individual computer, and it depends how many computers are out there. But yeah, we're talking for Bitcoin, it's tens of millions of nodes that are out there. It's just global and all over the world. And you'll find that actually the majority of nodes come out of China. But China has been cracking down on cryptocurrency and trying to get it banned. There's been more and more, and again, don't know the full specifics of why China's doing this, but who understands what China's doing? I'm trying to actually have control over what's going on over there. And so I'm trying to make sure that that's not something that they can't keep their hands on because they're always censoring. Just recently censored something. I don't know if you guys followed the NBA just being started or not, but one of the players on the Celtics said something about Taiwan, and then China again just completely knocked up everything about the Boston Celtics that you can search for through Google on the internet. So who really truly understands what they're trying to control? But I do know in Malaysia or Singapore, there were videos of the government steamrolling over people's mining machines and whatnot, because again, they were tapping into the country's electricity. And I guess for smaller places where you could bring the country down, if you use up and eat up all the stuff on the power grid, it could have a gigantic impact on that. So to answer your question, there's a lot, but it depends on the type of coin. Some coins won't have as many nodes because they're not as popular. And you'll see that sort of up and down just based on the value of the coins. Right now, we're kind of on an uphill run again, where everything is kind of going up again. So people are kind of jumping back into it to do more mining and whatnot. But these cycles, I've been watching them just happen up and down over the last decade. So I wouldn't be surprised if there was another crash again.
What do you mean by blockchain?
Excellent question. So when we say the blockchain network itself, so again, the blockchain itself is just a chain of blocks. And this actual chain of blocks lives on every single node of the system. So when we say network, we're just talking about all those nodes having identical information and having those blocks living on every single node. And this way you could see that transparency is supposed to be there. When we refer to the network, that's what we're referring to.
Okay, and then you also talked about the line of chain. And whoever's running the line of chain with that, is that kind of like not we were kind of, when I start up the line of chain, I'm always in the line of chain.
This, yeah, you're absolutely right. So with longest chain, what we're referring to is the new blocks that are going to be on there. So if you're assuming that at any given moment, you're going to have your network looking identical, everybody having the same number of blocks on each of their nodes. But then you might accidentally, like, well, not accidentally, but over time have mined a block. And then you might have mined a block. And then you might have mined 2 blocks. The idea of longest chain is that keep your blocks where they are, mined, they're unconfirmed by the rest of the network, but take the longest chain, add that to all the nodes first. That will be the first set that you add on, then add on the other ones. So it's a way of avoiding having forks in your system. Just one way of being able to do it. But the main reason being, you don't want your network to have different information on different nodes.
Doesn't that imply that those shorter chains have to be mined?
No, because what will happen then is in those shorter nodes, they will catch up. They will get synced up until they are caught up with everybody else on the network, except for the addition of those new blocks. So all of their mining that they're doing is meaningless until an actual block is discovered. So you could, even if you're mining and mining and mining and you're doing all of this, if you haven't actually found a new block yet, then that just stays in your local system. All that really matters is once you've actually discovered a block. Everything else is irrelevant up to that point.
Yes, that block that you discovered is dependent on the previous block in the chain. Right?
The hashing of it is, you've discovered it, but the previous hash isn't done yet until it's distributed. So you'll find that block and it's ready, it's unconfirmed, but then once it's added to the actual chain, once it's actually synced up, then it will use the previous hash of whatever was at the end of that longest chain that it's synced up to. I understand your question. What you're asking is, how does that work? If I've got a block and and you found it, it's using that last hash, but then those other long chains are also using that last hash. So how do you actually work that out? So when you find the block, from what I've seen when I was mining and whatnot, it doesn't use the actual last hash yet. It only does that once it's finally added into the end of that actual chain. So you'll find the block, you'll actually done the computation to solve it, but the actual finalizing of that process to adding that block isn't done yet until it's confirmed.
So replacing that chapter 6 is based on any nuts in the previous block. You're supposed to start with given nuts number and increment it, right?
When you're adding to the chain, which is a slightly separate process from the actual discovering of the block. So once you've actually found the block and you've discovered it through the computational calculation.
Okay. Following the block. Okay.
Sure. So again, this is going back into the proof of work algorithm and using that computation where it's utilizing, and again, it goes more into detail if you look at the Bitcoin actual white paper, but we can kind of talk about it to the way I understand it. But using that computation to be able to solve for the next block that's available, because here's something I should mention as well too, which I didn't mention. With the Bitcoin's proof of work algorithm, there is a finite number of coins, meaning you could keep solving and it gets more and more difficult when you're using this algorithm to solve it. But eventually there's a finite number of coins. So once you've hit all of that, there'll be no more. But the difficulty in being able to do that is exponential, where it will take way more computing power that we have to be able to hit that until we finally are able to properly tap into quantum computing or whatnot to be able to do things at a faster pace to be able to do that. Whereas other coins like Dogecoin and other coins, there are sort of proof of work algorithms that they use, which is slightly different than what Bitcoin is using, doesn't actually have a limit on the number of coins. You can keep mining Dogecoin forever, which is why people have always been speculative about whether this would have any value. Because if you can just keep making these things forever, why would it be worth anything? But I think that's something for another day. I don't really understand it.
Why would you bother?
Yes. Right?
For that matter, when you get to the first point, you can't buy, even even those crazy server farms and upstate New York can't mine.
Right.
Bitcoin, that's not the case.
Right.
And all the miners will who's maintaining the chain.
That's a great question. So if the diminishing returns go away, who's going to maintain the chain? So blocks are still being found because there's still enough work happening on the chain right now. If that ever happens, it would take an extremely large amount of computing power where you wouldn't get anything back, because you could still find blocks today with enough people working and computing at it, but you will only get a smaller fractional piece of it. They're all banking on the fact that that fractional piece will still be worth significant amount. They're talking like right now, Bitcoin's at, I don't know, 70, I should double check and see, 75, 76,000 or something, or maybe it's on its way up back up there again. But they're forecasting that Bitcoin might be worth like 500,000 in 5-6 years, maybe 1 million. So I don't know if it will truly ever go away, only because the price of it will keep going up. But in the case of other coins, you raise a good point. If those coins keep dropping in price, who's going to maintain all of this? Whoever owns wherever that coin is that has that server running. Oh, I should also mention, Chia was actually proposed by the founder of BitTorrent. I don't know if you guys are familiar with BitTorrent. Maybe, yes. But if they go away, if Chia goes away and they take down their server stuff, it does go away. So there is somebody that has to start it, and then the nodes have to keep going. And the thing is, as long as there's people on the network still going, you can still do this. But again, the question is that is the reward worth that risk at that point when it's not worth it to mine anymore, if there is a finite amount and it's more difficult to get to the next block?
That's the question. So let's say the Chinese government and I'll say their hydropower and all of
Sure.
the big farms.
Yep.
Realize that they've earned enough cash.
Yep.
They're not going to dump more.
Right.
And all of a sudden, the Bitcoin network goes from X million to X 100,000.
Sure.
With the hobby, like the basement.
Yes.
All of a sudden, executing the Bitcoin transaction currently takes what? Minutes?
Yes.
All of a sudden, it takes hours.
To find, you mean actual block? We see a transaction.
Transact with Bitcoin.
Sure.
If I want to go to my money transfer,
Right.
if I buy something on the network,
Sure.
I put in my Bitcoin transaction to their wallet, and then I have to go and see where my options are.
Right. Yeah.
Where they even get report the few remaining network nodes from that transaction. My vendor can verify it. So
Right. Sure.
How is that useful?
That's a great question. And that's why I think I've seen a lot of coins go down the tube because of that. The value wasn't there. And then all of a sudden you see the projects being abandoned. In fact, and that's why it's always sketchy. I've seen projects get abandoned where people will take it down and then your coins aren't worth anymore, but the people running it sold it, what they had quickly, and then got out of it because they realized they weren't going to make any more. And it's unfortunate, but that does happen. Now, back to your question, at least with Bitcoin, right now, because it's so widespread and it's all around, it's unlikely that that's going to happen where you're down just to a few thousand nodes and just hobbyists. But you never know. Like you said, maybe all of a sudden, the United States government says, you know what, no more mining. This is not useful. There's too much money laundering happening. There's other illegal things going on and whatnot. And if we're down to a few thousand nodes, what would happen? I don't know. But as long as you have at least a couple nodes operational, in theory, it should still work. And that's the whole idea of it being decentralized. But is it going to be worth it anymore? Probably not. And even now, the question is this only worth it if somebody's going to accept your form of payment, whether it be for cash or for goods and services? So now, again, in South America or in other countries as well too, they're accepting Bitcoin. You can go and buy a home with Bitcoin. But it's kind of weird, right? Because it's like you got something that was worth whatever it is, back in January, and now 4 times what it was worth now. Is it worth it to buy something with that coin now? Is it going to suddenly drop in price? So then the seller then loses money or whatnot. It's like, how do you put that value in there? How do you understand that? But to your question, I don't know what exactly would happen, but I would imagine that things kind of fall by the wayside if it doesn't provide value anymore to anybody else being able to utilize it. But I think what's interesting is how we've come from it being more of a hobbyist thing to being more mainstream. Like now I'm seeing, and I was just reading the other day that Domino's is going to start accepting Ethereum for payments for pizza. And as you're seeing more and more vendors buy into it, and because Elon Musk decided to buy, I don't know how much Bitcoin and is hoarding it, that's worth. They're saying he might be the first trillionaire because of SpaceX and his holding of Bitcoin and whatnot. But as we're seeing more of it becoming more mainstream, it's harder to see it go away. But it doesn't necessarily mean that it's the right way forward, if that makes sense. Because I still think that there's still ways where corruption and laundering and things like that could potentially happen. But yes, Domino's is going to start accepting it. And there's other vendors as well too. They're going to be, PayPal said that it's going to start adopting Bitcoin at some point as well too in 2022 as well. So that's a good question. And PayPal just bought Pinterest, I think a couple of days ago or whatever it is. So they were saying that also Pinterest will be accepting cryptocurrency as well too as payments for things as well. So I don't think it's just going to go away, but I think I'm not smart enough to understand the true reasons why this is going forward, other than the fact that people don't want just the banks handling all their money and maybe keeping those fees or whatnot. So funny story, which is kind of related, but not quite related. So I had to go take some cash out of US Bank the other day, maybe 2 weeks ago, just like $4,000, $3,000 or $4,000, but I had to take some cash out to go pay for some stuff. It was a Friday and I went into US Bank and I asked for that cash. And they said to me, they didn't have enough cash in the actual location. And I'm like, but isn't that strange? That's my money. It's sitting in your bank account. I need that cash. But they didn't have it. They said they could maybe give most of it to me in 1s and 5s, maybe. But otherwise, they said they didn't have it. So then it got me thinking more. It's like, this is the bank. It has your money. You don't know what they're doing with it, how they're investing with it, what exactly is happening, but you're trusting them with it. And for the most part, things are okay from that point of view. But if you just need your money and need to get it right now, it seems like you've got to jump over hurdles or hoops to get to it. So I know a lot of people are kind of feeling like they want a different system where the government and the banks can have their hands on there. But again, then it opens down doors to things that are maybe a little bit more illegal.
Why did the records take so long? Is it because infraction is validated, or because it seems like you only check the previous, because each previous law, you need to check.
Yeah, that's a good question. It does need to be, when you're doing transactions, they do need to be confirmed. Have you done transactions with Bitcoin or not? It does take time. I've seen, at least when I've been doing movements of, and actually I haven't really bought anything with Bitcoin, but I have moved stuff from one wallet to another wallet. And in doing that, I did see it take like a good 30 minutes before it actually did finally show up. And I don't know the exact answer for that. My guess is that it does have to be confirmed and has to be written to the blockchain, because this is an actual transaction that needs to be on there, and so that everybody can see it. And you can see all the transactions that happen. You'll see the originating wallet address and the destination wallet address, and you'll see it all there. My guess is that it just maybe does take time, but it shouldn't take that long. It should be getting faster, because I know they've been doing improvements on making that better, at least from Bitcoin's point of view. I know with Ethereum, and especially, I don't know if you guys are familiar with this huge new explosion in space called NFTs. Yeah. So I have seen, at least with another coin called Solara and Ethereum, that those transactions seem to be going super fast, but I don't know the reasons between the different infrastructures as to why one is faster than the other.
How big?
Let's find out. Kevin, can I use your machine? Yeah. Okay. That's a great question, to see how many blocks there are right now. I'm sure it's something crazy.
Obviously, and follow-up question on does every Bitcoin node
Yes, it does. That is true. Correct. Yes, every single node needs to have every single block, which, as I mentioned, with Chia at least, which I'm mining now, and I had some data corruption. It took, and this is nowhere near as big as Bitcoin, but it did take a full, I want to say a week before I was finally fully synced up. Now, the nice thing though is, even though I wasn't fully synced up, the process of syncing up the blocks is separate from the process of doing the actual farming. So I can continue farming and it'll just be unconfirmed until those plots can be added to the existing farms. But at the same time, that chain has to be backed up and, synced up and whatnot. So that will keep going while you continue your farming process. It's getting copies of everything. It's not doing computation, like as you mentioned, but it is doing work in the sense that it's getting copies of all those blocks that's missing in its existing chain. So that those blocks of information, starting with the genesis, every node needs to have it. So let's say you're starting to mine Bitcoin for the first time today. You're going to connect, get your server up and running. When you connect to get synced up, you need to get every single copy. So you'll just get copied, but you're not getting it just from one spot. You're getting it from all the different nodes on the network. So this guy's giving you a piece, that guy's giving you a piece, and then eventually that will all get assembled until you're fully synced up.
And by assembly, you mean my node is going to match up all the hashes.
Oh, no, those have already been all computed. You're just getting those copies.
Okay, so let's say my node starts putting lies on blockchain. Who calls me?
If your node starts putting lies?
Yeah, I say I put a node in.
Sure.
That has.
Right. Once something is confirmed and it's actually the software that's on all the other nodes. So the actual server itself, each instance, it's not just one. It's literally every single node is identical. So if it doesn't match up with something else, that software then that's on your local instance will then remove it and put in the correct nodes that it should be getting as copies from the other nodes on the network.
So if I own enough Bitcoin miners.
Sure. That's an excellent question. Yeah. So if you had like 99%
of the miners you get. So we don't even have to wait until the Salvador history. We just have to wait for the Chinese government to confiscate half of all of them.
Right.
All of a sudden they can set Bitcoin economic policy at work.
Yeah, absolutely. Right.
How goes that?
That's a good question. I don't know, but they're definitely trying to crack down with the mine that's happening in China right now. But I don't know for what purposes exactly. But yes, you're absolutely right.
So, well, this could just come down to the race between whether China or the NSA lines up with half of the remaining Bitcoin nodes, and then just and the local.
So the thing is, though, even if China or whatever group of majority had the majority of those miners, it just means then that they would get the majority of the rewards. There, if you go to the Chia website, it's way more transparent than the actual Bitcoin infrastructure, where you can see what country, what locations, not down to the person, just because all you have is that address as well too, but you can see where the actual distribution of those Chia coins are going. And for the longest time, I haven't looked in a while, but China was getting 35% of it. And it was actually, I think, giant farms that they have in China that are doing this farming, and the same thing with Bitcoin, doing this mining, that the majority of those rewards are going over there. And yeah, 35% is what I saw for Chia at least. Everything else is distributed throughout Europe, Canada, United States, whatnot. But that's what would happen if you own the majority of those servers. The rewards would then go mostly into your thing because you have more chances of hitting through trial and error, hitting and solving that next computational piece.
Well, yeah, getting the rewards is one thing, but reporting a false transaction is fine. Because the transaction is just a sign of the private key sign entry that says so-and-so sends this many Bitcoins to this other one, sign.
Sure.
Who validates the signature? Does every single node validate the signature? Well,
It's a good question.
I think the answer is no.
Yeah, I think, yeah, I'm not totally sure. My understanding is that every single node can. That'd be just impossible for them to do that. But I'm assuming that there must be what are called full nodes out there that are, I don't want to say more legitimate because that doesn't make sense either, but there is some sort of validation that is happening. But yeah, exactly.
So does it work out? The current effective central authority is
No, I don't know, but I'm going to find out and get back to you specifically because I know the way it's laid out and it shouldn't ever end up like that. But again, it's a good point. If you have 99% of all the miners out there, could you do something that would be illicit there? And I don't know. I don't think so, but you could potentially do something then with all of your miners or whatnot, but then you'd have to change something in that algorithm or software to make that work. But then at that point, if you own 99% of the miners, who's going to accept your coin or do anything with it? Because the value then would probably disappear. But yeah, exactly. It would just tank.
Are there things in the blockchain right now that are not?
No, I believe everything is a transaction that's there. I don't think there's anything else that's there right now, with Bitcoin at least. No, but excellent questions. Yeah.
Is there anything about Bitcoin or really to allow protection of self-healing?
Yes, the self-healing process again.
Self-healing.
Sorry,
Self-healing.
Dealing.
It's where you enter what looks like a transaction that's really money between them.
Oh, so are you asking then if you're juggling sort of transactions between different wallets? Those are called transactions as well too then. So, oh, I see, self-dealing you're saying. So sending money from your wallet to another of your own wallets. Yes, that.
Especially what I'm having in mind here is self-healing that it looks like a payment for a resource. I could make it look like Bitcoin jumped X number of dollars just by doubling.
Yes, actually, that's a very, very good point. So going back to, we don't know who Satoshi Nakamoto is exactly, but that whoever that wallet is has many tens of thousands of Bitcoin worth. I'm pretty sure it's over $1 billion is what I was reading at one point. But if they were to suddenly sell or drop or make things move or shift in that way, just like with Elon Musk, when he went and bought, I don't know how many Bitcoin, looked up real quick as well too, but that's worth a crap load of money as well too. When that happened, that all of a sudden brought the price of Bitcoin shooting up right through the roof. And then when he said, I don't know, he bought a bunch and then he said that they weren't going to be accepting Bitcoin payments for Tesla cars, then the price dropped back down again. So that news or that exchange of money between wallets could be a means of manipulating the price as well too. Because it seems like every time there's a tweet, like yesterday he tweeted something about Bitcoin and Ethereum and that helped push its price up again too, is affecting these markets, which is why it's very volatile and we don't truly understand how this all works or how it's going to be impacted going forward exactly. Because we're still, I think, still trying to figure it out. But yes, it's a good question. If you were to self-deal and take a bunch of stuff from here and move it over there, would it impact the price? I believe the answer to that is yes, given what's happened already with what Elon Musk has done and other things as well too in sort of that space. Does that answer your question?